Dr. Alex Guion. Alex was raised in a small village in France, the son of an administrative assistant and a carpenter. He and his brothers were the first in their family to finish high school, and that one step opened up so many more. Now, with four engineering degrees, including a PhD from Massachusetts Institute of Technology, research in Boston and Paris, and some of the world's largest engineering projects with ExxonMobil in Houston, today Alex serves as Chief Operating Officer of Raphe mPhibr, helping build one of the world's biggest, most advanced design and manufacturing campuses here in India for the nation. Backed by a $100 million raise, the largest in India's defense history, Raphe's mission is now entering full scale execution. He shares his journey to remind students that your story can start anywhere and still reach everywhere. Each day you show up with discipline, enthusiasm, and intent. You don't just shape up the path of yours, but also your country. When thousands rise with that intent, we don't just imagine an Atmanirbhar Bharat, we would have built it. Thank you so much, Alex, for taking our time today to address our scholars today. I would like to let the audience know that if you have any questions for Alex, please post them in the Q&A box and we'll answer them after his address. Thank you, and over to you.
Thank you very much. Can you hear me well?
Yes.
Amazing. It's a real privilege to be there with you today and to hear the great story from all the way from the beginning. I'll mention to all of you that one of my dearest friend was actually a scholar from FFE, and FFE changed his life. So when I moved to India a couple of years ago, I kept asking how to contribute, and eventually he shared with me his story from a small village in India all the way to doing his PhD in one of the best schools in the US. And that's how I think with Sudha ma'am and others, we started the discussion. I'm not seeing anyone, but I'll share my screen and share with you some of the stories that might help echo some of the words from Dr. Goel. Okay, I'll do this. Are you able to see the screen?
Yes.
Yes.
Thank you.
Wonderful. So first I start with a question. I don't know if you know which tree has this flower. So this is from a plum tree. I grew up in a very small village in the southwest France that had plenty of those. Actually, we didn't have any neighbors. All we had was trees like this. And there was one particular month where all of them turned white like this. It's just very beautiful. And I thought I would start the story from there. I grew up in a small village, less than 300 people. I think at the time it was 100. And at the bottom of this page here, you see that it's about half of my life that I spent there growing up. Today I'm 36 years old. And there are multiple people that actually have changed my life along the way, and I'm going to share about this. I think it echoes the message that Dr. Goel had around not only focusing on technical, but also on being well-rounded, leveraging the support system and the network, and how important it is to give back. So I'll walk you through this and share more stories along the way. So I left my village when I was 17, and the person who changed my life at the time was this gentleman called Francis Fréchinet. He was the 12th grade physics teacher. In my family, no one really finished high school. So, if you're passionate about mathematics and physics, it's hard to know where to go and what to do about it. He was the one who essentially told me what to do, where to apply, and give the confidence that everything will work out. So these kind of mentors actually play a big role in setting up the path, and then giving the right advice at the right moment to just keep on working at it. As a small story, this was his last year as a teacher in high school. And unfortunately, his wife at the beginning of the year was diagnosed with cancer. So after a couple of weeks, he decided that maybe he should stay home and stay with his wife. Eventually, we convinced him that we would be a really studious group, and that coming to school and teaching would be a good support for him, and it turned out to be one of the best things that happened for him and for us. He would bring us cherries from his garden, and we developed this very organic relationship as a group of students with him. And towards the end of that year, we were very lucky that his wife actually had remission on cancer, and we all had a really happy end of that final year of high school. Um, I think without him, there's no chance that I would actually follow the path that I did. And throughout, I would try to highlight some of those mentors that actually played a key role. So from there, from a small village, go to a small town, and then small city of 500,000 people called Toulouse. It's very cute. Studying was mostly inside, like most of you are probably doing right now, but outside was very cute. It turns out I didn't know it at the time, but it's the aerospace capital of Europe. So Airbus and a lot of subcontractors that are specialists in landing gear and all kinds of subsystems actually are developed there, and I just wasn't aware of it. I think that echoes also on the importance to network along the way and all kinds of people to know what's around us. So in France, the system is such that you first study for a couple of years and then you take national entrance exams, and those are fairly competitive. And then written and all, and then there's an acceptance, which took me to a bigger city, capital city, Paris. Share a fun fact there is when you go to a big city, sometimes from a small village, you have a different accent. And I remember people saying, you may answer all the physics questions, but your accent is like a peasant accent of the South, right? It stuck with me, but it doesn't really matter in the end. I think the moral of the story is it really doesn't matter in the end. So 19 to 22, I was there and I did 3 degrees. First, I was doing bachelor's, master's in electrical engineering, computer science. I think a lot of students right now are following those because there's so many opportunities. I grew up close to a nuclear power generation unit, and I was always fascinated by that. So I always wanted, in the back of my mind, to go and study nuclear. And so I did this double master's degree program and did a double degree, got a master's in nuclear engineering. And that one decision actually triggered a number of other things that ended up being really helpful for me. One of them was to start working on R&D, so applying that academic training to a research project. And I think it's good to encourage everyone to look for applying what you learn to a project, see how useful it is. I think often we hear about, I've learned all these things in mathematics, but so what? And I think it's very helpful when you start applying your mathematics, your physics to a problem, and you start seeing that it's actually helpful. In this case, there were 2 different kinds of problem. One is called non-destructive testing, where you're sending acoustic waves into a material, and you're able to image that material. Another one was the safety analysis of a nuclear reactor in the south of France. It was very compact and different, and it had to be assessed in terms of thermal hydraulics. So that initial experience was also helpful to figure out whether I was interested in doing research or going back to engineering and start working in industry. And sometimes testing like this is also very helpful. See where the strength lies and then continue to build on it. Then I met Professor Jacopo Bongiorno at MIT, who also changed my life. So the way it worked was for the second master's degree, there was a 9-month research program. And I was so excited. My dream was to go and study at MIT. So I found a way through a foundation that was supporting students like me to go and study in the US. And so the 9 month of master's research was fully funded. And Jacopo Bongiorno opened a position just for me to come and work on a project. Sometimes luck also works really well. There was a PhD student there that had been working for 2 years on a project and was sort of reaching a dead end. It took a couple of years to kind of wrapping it up. But Jacopo was not satisfied. He was not yet, how to say, he didn't have closure on this topic. So because of the support of that foundation, I could just go and do research and take a risk on not getting any results. Um, and then after 6 months, we kept on trying different things, and we found a way to solve it. So instead of just coming back to France and look for a job there, he offered me a PhD position in his group, and that really changed everything for me. I stayed in the US and applied for PhD, and he was one of those that understands that you are on a learning curve, and so he's one of those mentors that will help you where you are to get to the next stage. And those mentors are incredibly helpful. And if you have an opportunity through FFE or elsewhere to receive that type of mentorship, really helps you get to that level of skill set and understanding that is very difficult to get otherwise. I think the support system is really important. So from there, Greeks MIT. MIT is a wonderful ecosystem where you have both the theory and the science, but also the engineering and the labs to actually do things and close that loop. And in the end, try to innovate. It's a place also that's extremely diverse. So people come from everywhere, and there's this sort of environment that's prone to cross-pollination, discussions, all kinds of networks and support systems as well. So this is where I got my last degree, so PhD in nuclear science and engineering, and of course the research associated with it. So I'll just touch a little bit on this because nature is fascinating, and I hope some of you are fascinated by it as well. I wanted to show you two pictures. One is on the left side. This is the typical whiteboarding, and I encourage all of you to whiteboard as much as you can sometimes to test assumptions, test understanding, make hypotheses, simulate things in your mind, look at what you've learned and test it with someone else. At the end of the day, everyone now has access to a lot of information everywhere, but the thought process and making it visible to someone else can be helpful. Working on a problem with someone else can be helpful. Communicating strategies, taking some initiatives is very helpful. What you see here is a very nice, interesting problem of nature where if you dip something, let's say if you dip a card inside of a bucket of water and you pull it back, what you'll see is a thin liquid layer. And if you see that thin liquid layer, you can study it, and it has very interesting properties depending on how fast you pull, depending on the fluid in which you pull. And obviously on the physics side, it's interesting, but then also on the computational side, on the right-hand side, what you see is to solve these problems, you oftentimes rely on a lot of methods, computational methods that involve mathematics and physics. And in a nutshell, what you see is all kinds of discretization that changes close to the interface in red. I have a fly going around. And it's a fascinating kind of method that helps you refine and look at how nature behaves in particular areas and increase that resolution there and inform it. The impact of that kind of work is once you build a good comprehensive model of how nature behaves at that scale, then you can run a full-scale experiment and then validate it. And this is when you close the loop and realize that for that kind of problem, for those kind of conditions, we have now a good understanding of how this behaves. And usually you also explain what you haven't yet solved, and that becomes work for someone else, and it never ends. So to me, these kind of things are fascinating, and I'll show you more towards the end, more videos around technology and research as well. And from there, after PhD, then looking for R&D positions. So that took me to Houston. Houston has a lot of different kind of industries, and there were a lot of jobs around R&D that was hiring a lot of PhDs to build multi-physics simulations and platforms that were used in the industry. And this is where I met my friend, who is an alumni of FFE, and for whom I know that FFE changed his life, and that's why I am here today, and I'm very grateful that I can support FFE as well. So for the first 3 years in Houston, it was mostly technical. Essentially 100 PhDs and software engineers and all kinds of engineers working on a very big simulation platform that simulates how fluids work at the subsurface under the ocean. When you're producing resource at the subsurface level, and then how those fluid come up to the surface, and try to do that in an accurate way so you can invest in the right way and you can operate in the right way and so on. Now, in those 3 years, I learned something really important is that what Dr. Guo was saying, which is that it's not just technical. It also has to be communication. It has to be initiative taking. It has to be helping others, a whole set of other things, not just technical in isolation. And this is where someone else again changed my life. Her name is Jennifer Watson. Um, she was the manager who was overseeing all of the decisions for investments of ExxonMobil in one region of the world that was very prolific. So there was a lot of opportunity. There was a very large opportunity space. There's a lot of different engineering disciplines that was coming together and try to understand how you're going to develop this resource. There's a lot of uncertainty around it. There's a lot of different options you could do. And this is where individual engineering disciplines had to do work. And then someone had to integrate this into a decision quality framework and help the entire organization look at different options to develop these resources and then eventually invest a lot of money. So that took me to a role that was more on the cash flow analysis part, that was more business side. It felt like in 3 years, it was like getting an MBA on the job for large investments. And what was really interesting about this is the interaction that you have to have with other engineers and other disciplines, and knowing when to go deep and when to trust, and then integrate all that into cash flow analysis and all kinds of supporting analysis that helps the board make decisions. And ultimately, everything ended up at the decision of a board to invest $13 billion. So this was the most significant project that I've ever been a part of, $12.7 billion. It's a significant investment, so there's a lot of analysis that you have to do. And for that, I was the person that was running all of the analysis for all the economics and all the forecasts, which integrates all different kinds of engineering. Once you do that, it's not just one board of one big company like Exxon. It's also the board of all the other partners like Hess and CNOOC. And once everyone agrees that this is a good idea and everybody is putting the money down, then you also have to go and convince the government that this is a good idea. And then eventually you get everyone on board and this type of project get executed. Today, it's been 2 years since this milestone was reached. The actual infrastructure is somewhat built. Everything is on track. There were more than 10,000 jobs created after this funding decision. And this kind of infrastructure will operate for 20, 30 years. And some of it actually produces oil that comes to India today. So whenever you're driving around and going to the gas station, sometimes it's actually coming from there. And then someone else again changed my life. This is Vikash Mitra on left side. We studied together at MIT. This was a closed loop, sort of full loop circle moment. And I was a senior at MIT. We together organized a startup workshop in Hyderabad in 2016. We worked together for about 6 months, midnight to 5 a.m. in Boston, so that we would be on India time. And eventually the conference happened. We had support from state government in Telangana and central government. And then we really wanted to bring something back to India and do something in India. So, so at that stage, essentially, this is 2 years ago, I moved fully to India. This is now my Aadhaar card here. I'm a UP Vala boy. And this is my grandmother in the middle. She's 84 years old. She's coming here in India in 1 month. She will be visiting everybody. And now this takes us to Raphe. So Raphe, we just closed one round of 100 million, which is the largest in the history of India for the aircraft manufacturing sector. What you see on this image is a suite of swarm drones, which are on assembly line here. Everything is designed and manufactured here in India and nowhere else. We're very proud to try to build an infrastructure that puts the people first at the center of everything we do. We believe that nothing exists without people. So what you see here is a sketch of our building. It's almost finished. We have 150 people in research, 350 in manufacturing. We have dedicated cabs that picks up people every day and drop them off at home every day. We have about 6,000 meals from in-house chefs, and we take care of all healthcare for everybody. I'll just show you a 1-minute video from each vertical that we have that shows you that the mathematics and the physics you're learning today, actually you can take it to design. Once you're designing, then you can simulate it before you validate it to go to production and manufacturing. And once it's manufactured, you assemble it, and then you can actually fly it. And here you help essentially India invent, design, and manufacture everything here, as opposed to buying it from outside. So on the left side, you see electronics, essentially anything that you can think of as the nervous system of the aircraft, including wires. Second left is composites. Those are essentially airframes that are very lightweight, very aerodynamic. It helps you fly longer. It helps you fly in a stable manner. Engines. This is the first 3D printed, metal 3D printed engine that India has produced. Instead of a 3 kilogram engine, this is 600 gram. And what you see here is some of the design files. But you see the complex inner structure of it that helps you have a higher heat transfer and become more compact. All this gets printed in-house here. We have the largest metal processing unit, the most advanced of the country. So you can 3D print metals, you heat treat it to get the right properties, then you machine it, you test it, and then off it goes to assembly. And then the right side, what you see is final products. Just like birds, anything that flies can fly in formation. Those are called swarms. So those are distributed intelligence. They fly together autonomously. They talk to each other and they talk to you as a pilot. And you can do all kinds of things with it. You can do all kinds of surveillance with it. And this is tomorrow's technology. I have 4 things I would leave you with to close. I think some of it was said earlier, but the first one is your story can start from anywhere, but you can still reach everywhere. I hope that my story gives you confidence of that. Second, I think you saw that if you invest in your studies and academics as a foundation, everything you can build on top of that. It's really important to build strong foundations. So this is the time now, as you're in second, third, and final year, to build that foundation. And sometimes it means circling back on the topic, talking to more people, and just building that solid so that in the future you can continue to build on it. The third one is I don't think there is any success without support system, like mentors and family, friends, colleagues. And this is where I see FFE playing an enormous role in supporting everyone and building that network. And the last one is the one that was part of the bio. I really believe in this. I think if every day you show up with discipline, a bit of enthusiasm, a lot of energy, and intent to do something good, with a good philosophy, then everything follows. So I just encourage everybody to come every day with discipline, enthusiasm, and intent. And if everybody does it, then I think not only individual wins, but also the country wins. So thank you for your time, and it's a real honor to be there with you and to support you. And we'll do our very best to continue to support you.
Thank you. Thank you so much, Alex, for that inspiring note. We also have a few questions from our scholars. It's all right, we'll address them now. One question was, why did you change from oil and gas sector, energy sector to the aviation sector?
Oh, it's very simple. I love physics, and physics doesn't see any difference. I can take you to any lab, which is a oil and gas lab. You will find so many things. I'll take you to a nuclear engineering lab. You'll see all kinds of physics. Nuclear engineering, we had everything: materials, mechanical, computational physics, thermohydraulics, radiation, reactor physics, everything was there. I think with a curious mind, you always find ways to learn and to apply what you've learned. So those transitions, I don't think are that difficult. If at the philosophical level, it's there.
Great, thank you so much. The next question is, you mentioned, as scholars asked in the beginning, you said that in your 12th grade, a teacher changed your life with a kind of mentoring. Will mentors play such an impact in his life, scholar's life?
Yeah, I think so. I really think so. Yeah,
Yes,
definitely.
absolutely, absolutely. The next question is, are there any opportunities for civil engineers in the US?
You need engineers, of course. Oops, sorry. Um, Civil engineers, of course. Everyone needs civil engineers as long as there's infrastructure. There are civil engineers. Yes.
Great. The next question. So, of late, Raphe mPhibr is in the news. So, what is the business doing differently in India?
Oh, very nice question. Number one, it's investing in both designing and manufacturing. I think it's very important to have both so that you can actually do the closed loop innovation in-house under one roof so that if you're designing something the same day, you can manufacture it and test it and close that loop very quickly. So within a day, you might design a system, make it, learn from it, go back to design and close it. The other thing it does that a lot of people don't necessarily realize is if you own all of these machines and learn how to operate them, then you can also remove some of the constraints you would have otherwise. For example, if you rely on someone else for manufacturing, they might tell you, I can only do this kind of gear, I can only do this kind of, and it's going to take this much time. If you're doing it yourself, you realize that you can extend those constraints, remove some of them, and you have a lot more freedom. And as soon as you get more freedom, then you can create and expand new designs and invent new designs and invent new manufacturing process. So the other thing that we do differently is we invest in research long term, which is our process. So it's the founders of the company are scientists, and they believe in the scientific process. And if you follow the scientific process, you know that the outcome will be there. So I think slowly what you see is going after any technology that you require in order to innovate. And I think that as a philosophy enables you to do more and more and more and more things.
Noted. Thank you so much. Another question. How do we manage our time between academics, job preparation in our final year as students?
That's a good question. I always focus on the process and building strong foundation. So it's a trade-off. I think you have to be dynamic about it. You have to think about your strength as you go. I think most of you now should know my strengths are here. Focus on that, and then have a very thoughtful approach. Engage your mentors, engage your network, engage your friends, engage who is there with you in that support system to help you with different perspectives so that you can test your assumptions. And in general, don't isolate yourself doing just one thing. You have to balance both. Everybody understands that. The fine line between the two is a case by case basis. The best thing you could do is to really think about yourself, about the strength that you have, and then also engage others around you that knows you, who can advise you. That will help you debias a little bit your approach and hopefully help you do your best.
Noted. Final question for today is, what is the outlook for core jobs with AI?
Yeah,
Yeah,
and there is a
so
related question, Alex. Can you explain and deep dive into how AI works in drone specifically?
also so first, I think AI is like a generic term that is associated with a lot of things right now. There is still a lot of applications for traditional algorithmic programming. Then this AI layer, intelligent layer, can be used in many different ways. You can use it as a co-pilot for any function that is operating right now. Think of it as if you need to access a lot of data, if you need to access a different kind of thought process. If you want to streamline interfaces and all, that can definitely do that. When it comes to pattern recognition, when it comes to learning over time, obviously it's very helpful. Any form of intelligence like this can be given to a computer and do it much faster and in volumes and rates that are much greater than a human pilot. And so obviously it's a tremendous help. I don't think it will replace everything. I know that there's a lot of debate right now, so I won't get into this, but there's still a lot of needs that we have today where AI won't come in and change it. One of the hardest things to build is culture. For example, if you're building anything that is bigger than yourself, you're going to need a lot of people to help you. And right now, I don't see AI really changing that. And I think it echoes also what Dr. Guo was saying around make sure that you don't only build technical skills, but also think about being well-rounded. And I think that's really important as you work in a group and work in any kind of initiative that requires multiple people and interfaces. It becomes just as important as the work.
Noted. Thank you. Thank you so much, Alex, and for this insight.
Alex, there are a lot of questions in the Q&A box. The paucity of time, we won't be able to take all the questions, but we'll definitely like to invite you one more time for our scholars to, take more of such information from you. One last question, maybe, which we can ask you, and somebody wants to know why India and why not any other place? Is there any potential for India to grow and nurture more startups? That's the last question for the evening.
Yeah, of course. I think so. There's my personal story, and then there is the bigger story of the country. But my personal story is 12 years ago, Vikash and I used to say that we're brothers from another mother. And so when we had the opportunity to be reunited, I jumped on it. Second, I think the culture living in India now for 2 years and what I saw growing up in France is actually very similar. Relationships are very important. I see a very big difference with the US. I have a lot of friends who move from France to US actually don't like it and return to France. Same thing with India. I have a lot of friends who struggle there because the culture is very different. In India, there's such a huge opportunity right now to build projects that actually push the country forward. And for every new project, every new innovation that becomes the first for the country, you're actually pushing the country forward. And I find that extremely motivating. And I don't know any other place where I would feel that motivated.
Thank you so much, Alex. Thank you, Tanvi, as well. Thank you so much, Alex, for this really insightful session. I'm sure there was a takeaway for each and every one present here. Thank you so much for that. So, Dama, if you'd like to offer a few words of thanks to our esteemed speaker, please.
Yes, it's always a pleasure to have you, Alex. And I think lots of takeaways for our students. Amazing to hear your journey and your aspirations and how you've been able to fulfill your dream. And it's flying high, is what I see. Literally, figuratively. It's wonderful, I think, for our engineers to hear how technology works and how you can bring your foundational learning to life. And you've demonstrated that. And if for us non-engineers, it's truly very inspiring as well. So happy that you could join us. And I know, as Tanvi mentioned, we have a whole lot of questions from a large audience, 1,500 students who've joined. With your permission, we'd like to, we'll have this recorded and circulated. And I think we know that we'd like to have you back as a webinar speaker. Very technology oriented webinar. And I think there's a lot of hunger for learning. And you've made that possible, Alex, through your own very inspiring story. So thank you. And I think our audience here is eager to hear you again. Thanks for making time.
Thank you.
Thank you so much. Thank you so much, Sudha ma'am. Ram, if you'd like to add a few words.
No, I think it is always inspiring. Thank you, Alex. I know the entire nation is behind after the work which you've already done, and getting your time is has been phenomenal, and the simplicity at which you actually articulated things so inspiring, and how to live simple, how to make everything simple, how to stay humble and inspire others and get inspired by others and keep learning those things. And actually, the drive of learning which you have is so inspirational. I'm sure it motivates. While I've met you, heard this one, seen the kind of great work which is happening in the R&D facility and the manufacturing we've built. And I mean, it was like a dream that we've been probably in some other country, developed country, extremely developed country. So thank you for actually relocating to India and doing this great work, and great to see your inspiration story. We'll stay in touch and we'll catch up again. Thank you.
Thank you, sir.
Thank you, Ram. And thank you, Alex, once again for your time this evening.